What if I told you that inside an AI, there's something that looks a lot like a brain? Not a fleshy biological one, but a complex, organized system with different parts for different jobs. Well, a fascinating new study did just that. It peeled back the curtain and found a specific region inside a large language model that they've named the coding spot.
All right, so here's our game plan for digging into this. First, we're going to tackle the big question. Can an AI even have a brain? Then, we'll put on our detective hats and look at the exact method researchers used to hunt down this spot. After that, things get dramatic when we see what happened when they switched it off, which leads right into the jaw-dropping results. And finally, we'll wrap up with what this all actually means for the future of AI.
So first things first, to really get this, we have to start with the core idea that sparked this whole investigation. And it's an idea that comes straight from neuroscience.
Think about our own brains for a second. They're not just one big soup of cells, right? We have specific zones for specific things, like Broca's area, which is a total superstar when it comes to speech. For the longest time, though, the thinking on large language models, or LLMs, was completely different. They were seen as this massive, messy black box, just a web of billions of connections where information was kind of smeared everywhere. The big question was, is that really how they work? Or are they quietly organizing themselves into specialized departments, just like our brains do?
So, running with that brain analogy, the researchers had this hunch. They figured if an AI is great at coding, there must be a dedicated part of it that handles that skill. And they gave this theoretical place a name, the coding spot. They defined it as a very specific group of parameters, you can think of them as the AI's neurons, that are absolutely crucial for its ability to write and understand code.
Okay, so you have a theory. But how on earth do you actually find a tiny little spot in a digital brain that has billions and billions of parts? It's a genuine needle in a haystack problem. So let's get into the method, because how they pulled this off is brilliant. The researchers came up with this really clever 4-step plan. First, they took their AI models and basically sent them to coding boot camp, training them on code from 10 different programming languages. This was designed to light up all the parts of the AI's brain related to coding. Then, step 2, the really cool part, while the AI was learning, they calculated something called an importance score for every single one of its billions of parameters. This score tells you exactly how much each tiny little neuron is contributing to getting the code right. Step 3 was all about finding the MVPs. They added up the scores for each parameter across all 10 languages. This was key because it helped them find the parameters that are crucial for the concept of coding, not just for one language like Python. And finally, step 4, identify. They took the tippy-top percentage of parameters with the highest universal scores, and voila, that was the coding spot.
And this visual really helps it all click, right? You can literally see the process here. They measure the importance for each language separately, then they stack all that data together, and it lets them zoom right in on that one critical area, that dark red spot, which is the coding spot itself. It's a process of elimination on a massive scale.
So, they found it. After all that work, they pinpointed the exact location. Now for the fun part. What happens if you break it? This is where things get really wild. They decided to perform a little digital brain surgery and just switch it off.
And get this, we're talking about a ridiculously tiny piece of the AI, just 0.09%. That's less than 1/10 of 1%. I mean, it's practically nothing. What could possibly happen if you flicked such a tiny, insignificant switch?
Well, let's just say the results were shocking. This wasn't a little glitch or a minor bug. Deactivating that tiny spot led to a complete and catastrophic system meltdown.
Just look at these numbers. It's absolutely insane. On a standard coding test, the LLM model was an A+ student, scoring an almost perfect 97.5. After they deactivated that tiny coding spot, the score plummeted to 0. Not a failing grade, not a low score, a literal 0. The skill was just gone. It had been completely and totally erased.
But it didn't stop there, and this is where the plot really thickens. It turns out breaking the coding spot didn't just break coding, it also made the AI significantly worse at math and logic problems. This is a huge clue that tells us the AI was using the very same brain region for both of those skills. But here's the twist. Its common sense reasoning was pretty much fine. It's like the AI completely forgot how to do calculus, but it could still tell you that you probably shouldn't wear shorts in a snowstorm.
Okay, so we've seen the experiment, we've seen the shocking results. What does all of this actually mean? Let's break down the big conclusions from this whole thing.
This is really where it all comes together. First, We now have proof that a tiny, hyper-specialized area inside an LLM can be entirely responsible for a massive skill like programming. It's not just a diffuse cloud of knowledge. Second, and this is a really cool term, they found the area is polysemantic. That's just a fancy way of saying it's a multitasker. It's the central hub for both coding and logical reasoning, which shows us just how deeply those two skills are connected inside the AI. And that leads to the biggest bombshell of all. LLMs are developing internal structures that look way more like brains than we ever thought. This totally shifts our view from the black box idea to seeing them as complex systems with a real internal anatomy. And finally, it turns out not all AI brains are built the same. The study found that different models have different coding spots, which means we might be able to build smarter, more efficient AIs in the future by designing these specialized modules from the ground up.
Now, of course, no single study answers everything, and good science is always upfront about its limits. The researchers made it clear this was only done on llama models, so we're not sure if GPT models have a similar spot. Also, the exact size of the coding spot was an educated guess based on their data, not a hard and fast rule. And their method for switching it off, setting the numbers to 0, is just one way to do it. But honestly, these aren't really flaws. They're basically a to-do list for future research, which is super exciting.
Okay, wow, that was a ton of information. If your own brain's parameters are feeling a little fried right now trying to process all that, I know just the thing. The YouTube channel VibeDoc. I can personally guarantee that hitting subscribe will boost your mood score by 100%. Look, it's not peer-reviewed science, but it just feels true, you know?
And that's really the thought I want to leave you with. We found the coding spot. It feels like we've just discovered the first major city on a map of a totally new continent. So the real question is, what else is in there, waiting to be found? Could there be a creative spot, a little corner that handles humor, or maybe, just maybe, even a region for something like empathy? We are literally just beginning to explore the minds that we're building.